Hey guys. All right. So we're continuing our discussion on what we call the remainder theorem. So in the previous video, which is definitely attached to this lesson as well, we talked about long division and synthetic division. Okay. Now, what we're doing over here, we talked about when we're doing these divisions, we're saying we're taking a polynomial p of x and we're dividing it by x minus b. Okay. Now, what this question is saying, for each question, evaluate p of b. So what we're doing then is we're taking whatever this b value is here, and we're putting it into the x of p of x, and we're putting in for all the x's and then seeing what it equals. So I'm just going to go back to example over here. So when our b value here is 2. Okay, so this was p of x divided by x minus b. So therefore, b equals 2. So that means we have 2 cubed minus 4 times 2 squared plus 2 times 2 minus 5. 2 cubed is 8. 2 squared is 4 times 4 is 16. 2 times 2 is 4 minus 5. So 8 minus 16 is negative 8. Plus 4 is negative 4, minus 5 is negative 9. Okay. Now, what we saw before, and sorry guys, I erased my notes from before. When we did this guy with synthetic division, we saw that our remainder was negative 9. This was our remainder, right? These numbers match up. Okay. If we do this guy over here as well, okay, so I'm going to put in a 5 in for my x's here. I get 4 times 5 cubed plus 2 times 5 squared minus 2 times 2 minus 9. 5 cubed is 125 times 4 is 500. 25 times 2 is 500 minus 4. Sorry, this is 50, not 500. Minus 9. Okay. All right, so sorry, my mistake here, guys. This is 2 times 5, this is minus 10, minus 9. Okay, so we get 500 plus 50 is 550, minus 10 is 540, minus 9 is 531. When we did our synthetic division again, the answer was so this 531 was our remainder, which is matching up with this number over here. Doing it for this one, so we're dividing p of x by x minus negative 1. Therefore, b equals negative 1. So we're going to put in a negative 1 for our x's in this question. This is negative 1 to the 5th plus 2 times negative 1 to the 4th minus 7 times negative 1 cubed plus 2 times negative 1 squared minus 6 times negative 1 minus 9. This is negative 1 plus 2 plus 7 plus 2 plus 6 minus 9. This is 1 plus 7 is 8 plus 2 is 10. 16 minus 9 is 7. Again, our synthetic division was put in the 1, we multiply and add, we multiply and add, and again, our remainder matches up with this number over here. So the pattern we're trying to develop here is, what is the remainder theorem? The remainder theorem says when a polynomial function is divided by x minus b, the remainder is R equals P of B. So what this means is to find the remainder, plug the B value in for all X values and evaluate. Okay, so what's that mean for questions like this? So for example 5, we are asked to determine use remainder theorem. So in this case, here's our P of X divided by X minus B, therefore B equals 4. So we want to go 5 times 4 cubed plus 2 times 4 squared minus 4 plus 3. When we do that, we get, I'm just going to do this on my calculator here, 5 times 4 cubed plus 2 times 4 squared minus 4 plus 3 equals 351. Okay, so here's our answer for this guy over here. Okay, let's confirm this using synthetic division. So if my b value is 4, I have 5, 2, negative 1, 3. 5 comes down. 4 times 5 is 20. 20 plus 2 is 22. 4 times 22 is 88. Negative 1 plus 88 is 87. 4 times 87, just doing this with my calculator, is 348. 3 plus 348 equals 351. So this is just kind of confirming this over here. So if a question asks you to use a remainder theorem, we're talking about this method over here. It says plug in the b value in for the x's and get your answer. Okay. Here, our b value, we're dividing by x minus negative 1 because it has to be in the form x minus b. So therefore, b equals negative 1. So this is going to be 3 times negative 1 to the 5th plus 6 times negative 1 squared minus 2 times negative 1 minus 2 is negative 3 plus 6 plus 2 minus 2 equals 3. Okay, so our remainder is going to be 3. Okay, C. So this is P of X divided by X minus B. Therefore, B equals 3. We get 3 cubed minus 5 times 3 squared. So again, we're just putting in the value of 3 everywhere we see an x in P of X and evaluate it. This is 9 times 5 is 45 plus 21 minus 3. And I'm just going to do this on my calculator here. And we get an answer of 0. So that means remainder is 0. For example D here, we need to go ahead and we need to factor out the leading coefficient of the divisor. So for this, again, we're dividing by x minus b. This value here is going to be that. Okay. So now for this guy, we have 3 times 1/3 cubed minus 1/3 squared plus 4/3 minus 1. I'm just going to go straight to my calculator for this guy. And we'll do this. and we get a remainder of 1/3. Okay, so that's how those guys work using the remainder theorem. So for example 6, okay, you'll see these type of questions on your quizzes and tests for sure as well. So this is saying kind of almost like a working backwards question. So we're telling you what the remainder is, but then we're asking you to solve for this k value here. Okay, so when the polynomial is divided by y minus 3, the remainder is 12. What's the value of k? So what we're doing here is if we're dividing by y minus 3, okay, therefore 3 is the b value. So we're going to plug in 3 in for the y's here, but we know that this equals a remainder of 12. So we get 3 cubed minus k times 3 squared plus 17 times 3 plus 6 equals 12. Okay, and there's a bit of algebra. Let's solve for this k. So this is 3 cubed is 27. 3 squared is 9k. 17 times 3 is 51, plus 6 equals 12. So I'm going to do this. I'm going to get k by itself now. So I'm just adding 9k to both sides, and I'm subtracting 12 from both sides here. So now I'm just going to use my calculator for this. We got 27 plus 51 plus 6 minus 12 is 72. Divide both sides by 9, and that means that 8 equals k. Okay, so we solve for this for 8 equals k, and that's our answer. Okay, so again, strategy was plug in the b value in for your y's. B value is 3. We know the remainder equals 12, and then solve this equation for k. Example 7 is similar. I guess there's a typo here. This should be mx squared. Okay, so when we divide by x plus 4, we divide the polynomial by x plus 4, the remainder is negative 18. When it is divided by x minus 3, the remainder is 80. Algebraically determine the values of m and n. So guys, anytime you see the word algebraically, it always means show your work using methods taught in class. So in other words, if you just put an answer for this and don't show any work, you'll probably get a 0 for your mark. Okay? So you need to be able to back up your work, kind of showing methods that you can learn in class here. All right, so this is very similar to the last question. Okay, the thing is we're dividing by 2 different things. We're getting 2 different remainders. But the thing is we're looking for an m value and an n value, so we have to solve for 2 different things over here. So when we're dividing by x plus 4, this is the same thing as x minus negative 4. So therefore, b equals negative 4. So we're going to put negative 4 in here. So this is going to be 2 times negative 4 cubed plus m times negative 4 squared plus n times negative 4 plus 2. That remainder is negative 18. Okay, so I'm just going to clean this up a bit. Negative 4 times 2 is negative 64 times 2 is negative 128. Negative 4 squared is positive 16m minus 4n plus 2 equals negative 18. Okay, so I'm going to add 128 to both sides, and I'm going to subtract 2 from both sides. So we're left with 16m minus 4n equals 108. Negative 18 plus 128 minus 2 gives us 108 here. And one thing we can do as well, we're allowed to divide both sides of this equation by 4. Okay, so this is going to be like 4m minus n equals 27. Okay, I'm going to call this equation 1. Here is the first part of the question over here. So when it's divided by x plus 4, the remainder is negative 18. When it's divided by x minus 3, the remainder is 80. So we're going to do the same thing. So if we're dividing by x minus 3, therefore b equals 3. We're going to plug a 3 in for the x's here. This remainder is 80. 3 cubed is 27 times 2 is 54. 3 squared is 9 plus times m is 9m plus 3n plus 2 equals 80. Similar to what I did in the last question, I'm going to subtract 54 from both sides and subtract 2 from both sides. So we get 9m plus 3 plus, guys, this is so frustrating. Every time I click something wrong, I lose the page. So 80 minus 54 minus 2 is 24. And the same thing, I'm just going to divide this by 3 as well. 3m plus n equals 8. Okay, this is equation 2. So what we have here is we have two equations, equation 1 and equation 2, with two variables each. Now you can't solve an equation with two variables, but if you have two equations, we can solve a system of equations. Now we studied these in Math 10 and Math 20. This is like when we solve by elimination or by substitution. So what I'm going to do as well is I'm going to group these two equations together and write this directly below it. Now this is set up really nicely to solve by elimination, because if I add these equations together, 4m plus 3m is 7m. The n's eliminate, and I get 35. Divide both sides by 7, and we get m equals 5. Okay, so solve for m. Now I need to solve for n. So I'll just use this equation here. We have 3m plus 5. Nope. 3 times 5 plus n equals 8. That's 15 plus n equals 8. Minus 15 minus 15. That means n equals negative 7. Okay, so the solution we have here is m and n equals 5 and negative 7. Okay, so if we read like an ordered pair like this, we're saying that m is 5 and n equals negative 7, which is what we were asked to solve. Okay, so guys, this is definitely the hardest question I think that we've seen in this unit so far. You'll see a few in your textbook like this, and I'll fire you off a couple in some reviews here too. Hopefully these questions make sense. All right, guys, we'll see you in the next video, which is called the factor theorem.